talking how when you guys are working with fractions, I'm just going to go ahead and say graph paper is going to be one of your strongest tools to use. Some of you are drawing in your notebook. I'm going to push you to graph paper because in fractions things have to be equal. So we have 3 different types of graph paper we've been using though. And if you don't pick the right paper, the right graph paper, the right array, it can really mess up your problem.
Jen, was it always part of your plan on this day to deliver the grid mini lesson?
No. The original plan was to go over more word problems. However, when students were working with fractions, trying to figure out which fraction was larger or smaller than another, they were choosing the wrong grid paper. And if they picked the wrong array in order to show a fraction, it was really hard to even begin for them to understand which fraction is larger. So I felt I needed to have a discussion about how do you find the perfect grid paper in order to help compare fractions.
What is the mathematical significance of choosing the perfect grid?
The mathematical significance would be to have students begin to think about common denominator. What is a common multiple those two numbers share? I'm going to make 3 columns on my paper for each of these. Okay. Let's start with the one we started with, 10 by 10. How many squares are on a 10 by 10 grid?
100.
Okay, 100. Let's write down 100. Draw a little line. So 60 is our last one. Don't worry about your column being perfect. Let's just get it down. Okay, if we can find the factors to 100, 24, and 60, it is going to tell us what grids to use. Okay. Really quick, I know 2 factors for every single one of those numbers right now. I know at least 2. What are the 2 that I'm thinking of for every single number up there? The 2 fastest ones. Okay, Rose? Okay, so you're noticing whatever the array is, those are factors, right? You're right, actually, K-Rose. That is even a quicker way. I'm going to write those down. Okay, 10 is a factor, 6 and 4 are a factor. I'm going to write them in pairs, actually. And I'm going to use a different color for fun. Okay.
The second thing I wanted to ask you about was the question you just asked the students. When you said, I'm just paraphrasing, I'm thinking of the easiest pair.
I can think of 2 factors right away for each one.
Yeah.
So I guess I'm assuming then, I'm assuming a few things. I'm assuming 1, that it's going to be hard for them to find factors. So I'm thinking of the 2 easiest ones. Because in my head, I'm thinking of 1 in the number. I'm assuming they're thinking what I'm thinking. I'm assuming that they need me to find the factors. That's what I'm assuming. That I have to give them to them. You think that's the best way to show it?
Yes.
12 and 5 are factors of 60. 6 and 4 are factors of 24. 10 and 10 are factors of 100. Now, what are the other 2 quickest ones I'm thinking of? Brianna?
100 times 1.
Okay, 1 in the number. So this would be 100 times 1. This would be 24 times 1. This would be 60 times 1. Chris?
Why don't we give him a minute to fill them all in?
Good call. You guys get that?
Yes.
All right. Fill in as many as you know for each number.
Okay, so at this point, the students are seeking out factors, and they're seeking them out individually. And then I asked you if they could work with partners. Can you describe how that impacted the room?
Yes, because at first it was dead quiet when they were working on their own. And I don't really know how many of them were finding success. It was very isolated. But as soon as we said partners, the volume, it became more relaxed, I guess, too. And there was more conversation about finding factors. So kids were sharing their ideas more.
May they work as partners?
Yes. They may work as partners. Okay, 10 times 4 is 60. 10 times 6. Okay, so I know these are even numbers. I know too. If you cut 100 in half, how many would be 100? What do you think? How far? What do you want to put 2 by?
Brianne, can you start filling in factors of a 10 by 10?
Try to find what equals the top. Try to times the top.
What's down by 100?
And if you do 1 times
We make your 5 just a little bit more clear.
and you try numbers.
You want to add one up there?
I don't have
That would go with this one.
I have 6 times 60.
It made that activity continue on, where some kids might be at a dead end. As kids are putting up solutions, it's kind of keeping the engagement, because kids want to write on the board, so they're seeing which ones they have, which ones they can add, and then at the same time, kids who don't have any are adding them up there. And then I don't have to have a whole class discussion. Who has this one? Write it up there. Who has this one? Write it up there.
Yeah, who's leading the class at this point?
Yeah, the kids are, the students are. So that was important. We're only going to go one at a time, so just hang on for us.
Oh, there it goes.
I got one.
You don't have to put that. Okay. Does anyone else have one that's not up there? Danielle and Tayshaun, put yours up. Which one are you looking at? Okay. Oh, that's up there.
All right, Jen, we've got to talk about 33 and a third and 10 by 3 by 2.
Mm-hmm. Yeah.
They were definitely some things that we hadn't maybe expected.
And your first instinct is to not let that kid go up to the board because it's confusing. So with 33 and a third times 3 to be a factor of 100, I thought that was okay. I would have left that and probably not had any conversation about it. I guess for both of them, I would say that I wouldn't have any conversation about it, because in my mind, a factor was a number that goes into another number evenly. I've learned a little bit more now in prime time, which the kids will be doing next year at the middle school. They define a factor as one of two or more whole numbers that are multiplied to get a product. So in that case, 33 and a third times 3, 33 and a third would not be a factor. So neither would 3.
Grady says 24 is a factor of 8 and 6. Is that correct? He's on the right track. Grady, you're on the right track, but you chose the wrong term. Eight and 6 are factors of 24. Austin?
Is it a multiple?
That's correct. 24 is a multiple of 8 and 6. In fact, 24, you guys have just discovered something really important with fractions. 24 is called a common multiple. So what you're actually looking for, what Ms. Rivas has shown you how to do is a strategy for finding the common multiple of 8 and 6.
Say that again, Chris. What's a common multiple? 24?
24 is a common multiple of 8 and 6. It's a multiple that they both share. So it's been about a week or more since you did this lesson.
Mm-hmm.
Did you notice any impact that this had?
I noticed kids, I think in the beginning, they just grabbed any graph paper without even questioning if it made sense or if it worked. Now they're not perfect at finding the perfect grid paper, but they're more aware that if one's not working, okay, I'm going to try another one. Where before, I can't say they would have done that.